Okay, the next section we're going to look at is section 1.5, which is on solving quadratic equations. So I said earlier in the course that the whole first chapter is about solving lots of different types of equations. And so the first type we want to get comfortable with is a quadratic equation. So first of all, what is a quadratic equation? Well, it's anything in the form ax squared plus bx plus c. And it's an equation, of course, and the b term may or may not always be there, but the x has to be squared, or x minus 2 has to be squared something. You've got to have that squared variable term as your highest power in the equation. There's four main methods we're going to look at for these. The first is factoring. So solve by factoring and using what's called the zero product property. And this is kind of a hierarchy of what I would try. I would try factoring first to see if that works. The second method is to use what's called the square root method. So if I see that it doesn't factor, I'm going to check to see if I can use the square root method, if it's a good option for the equation. And then the third option, if those don't work, is to try completing the square. So complete the square is a method you can use under certain conditions, or it's best under certain conditions, and I'll show you those. And then kind of as a last resort is the quadratic formula. So you may have learned that in high school somewhere, and we're going to refresh that again. I'll tell you that formula. So let's take a look at example 1. This is in the guided notes. So we've got 2x squared plus 7x equals 4, and the question wants us to solve this. Now, I suspect that this may factor, so to see if it factors, I've got to set it equal to 0 first. Before we do any factoring, we have to have the equation equal to 0. So I'm going to subtract 4 from both sides, and so I have 2x squared plus 7x minus 4 equals 0. And I think this does factor. If you remember the method I showed you back in chapter P, the second PowerPoint, or the second video rather, and I showed you something along these lines. 2 times negative 4 was negative 8, and then b is 7. That goes in the bottom of this little diamond. This is called the AC method. If you can find numbers that multiply to negative 8 and add to 7, this will factor, and I believe 8 and negative 1 will do it. I'm gonna skip the rest of that method. I'm just gonna use guess and check here to solve this because 2x is a prime number. So I know that the first two terms have to be 2x and x. There's no other option. And then I need numbers that multiply to 4. So it's either got to be 4 and 1 or 2 and 2. Since I need to get that 8 in there, I'm going to go ahead and put the 4 here because 4 times 2 would give me an outer expression of 8x, and then I'm going to put the 1 here. And then we need the 8 term to be positive, so I'm going to put the positive 4 there and put the negative here, and that should do it. Try it if you're not sure. Just make sure you see it. Guess and check a little bit or FOIL it out to make sure you see that gives us that original expression. And so the zero product property says once we've completely factored it, we can set each of these factors equal to 0 to solve the equation. So I have 2x minus 1 equals 0, x plus 4 equals 0. So I have 2x equals 1, and then x equals 1/2 when we divide by 2. And then over here, I'm going to subtract the 4 from both sides, and I have x equals negative 4. So those are my two solutions that I've got using the zero product property. So if the equation factors, I'd say that factoring using the zero product property is probably the easiest way to do to solve the equation. Sometimes that doesn't work out though. So if you take a look at the next example, example 2, they ask us to solve the equation 4x squared equals 20. We actually could move the 20 and factor it. That could work for this. However, if you notice that we have an x squared term, we've got a 4 in front of it, but we don't have any other x term, right? So in other words, the thing that's being squared is the x, and we can isolate the x squared pretty easily. So if we can do that, we're going to use what's called the square root method. And so isolate first the thing that's being squared. So to isolate that x squared term, I'm going to divide both sides by 4. So the 4 goes away, and I'm left with x squared equals 5. And then we need to go ahead and take the square root of both sides. And when you take the square root of both sides, you need to remember that there's two square roots, a positive square root and a negative square root. In other words, if you square a positive, it gives you a positive. If you square a negative, it still gives you a positive. So the solution here is going to be plus or minus the square root of 5. And that's all we're going to do. So that's called the square root method. If you take a look at example 3 in the guided notes, we've got x minus 2 squared equals 6. So this time the thing that's being squared is the x minus 2. Notice that it's by itself, so I'm going to go ahead and take the square root of both sides. In other words, you don't want to FOIL this and multiply it out and get the 6. That's going to make it a more complicated problem. If you've got the thing that's being squared isolated, go ahead and use that square root method. So we're going to take the square root of both sides. So the left side, I have x minus 2. The right side, I've got to have plus minus because I inserted the square root, so plus minus the square root of 6. And then we need to solve for x, so I'm going to add 2 to both sides. So I get x equals positive 2 plus minus the square root of 6. And that's going to be my final answer. Okay, so let's take a look now at example 4. We've got x squared minus 4x plus 2 equals 0. And I want you to pause a minute and notice that this expression cannot be factored. In other words, there's no numbers that will multiply to 2 and add to negative 4. So factoring is not an option here. The thing that's being squared is the x squared term. That's what's being squared. But notice that I have another term with x. So I can't easily solve for x squared. I mean, I could move the 2 and I could move the 4x, but then there'd be an x on this side and an x on this side. That doesn't help me. So the square root method does not apply here either. So we're going to go ahead and try completing the square. This would be kind of my third choice of options for solving these. So completing the square is a good candidate to be used when two things are true, okay? So the one thing with completing the square that you want to look for, let me go ahead and write this down. The one thing for completing the square that you want to look for is that the leading coefficient a should be 1. Completing the square can be done anytime, however, it's easiest to use when the leading coefficient equals 1. Additionally, the other thing you want to look for is that the b value is even. So if the b value is even, and you'll see why in a second why that's important, that'll help you out. So notice that's what we have here. The b value is negative 4. The leading coefficient is 1. So let's go ahead and go through the steps to complete the square. So I'm going to rewrite the problem again down here. And this seems a little daunting at first, but once you do a few of these, you'll have the method down. So first step is to move the constant term to the other side. So I'm going to subtract the 2. So I have x squared minus 4x equals negative 2. And then somewhere off to the side, I'm going to take that b value, in this case the negative 4, and I'm going to divide it by 2. And that gives me negative 2. You always divide by 2, which is why I said this is best to use when b is even, because otherwise you'd get a fraction. Next step is you're going to square both of those, or rather square that number that you just got. So negative 2 squared gives me a positive 4. And then go back to your equation and take that number that you just squared, and you're going to add it to both sides of your equation. So notice I added 4 on the left side, I added 4 on the right side. Remember, we can do anything we want to an equation as long as we do it to both sides. And so let me simplify that right side. So we have x squared minus 4x plus 4 equals positive 2. And then that left side, if you'll notice, is now going to factor. Take a look. This will break down. This is a perfect square trinomial. It'll break down into x minus 2 times x minus 2. And think about how we could shorten that up a little bit. X minus 2 we could write as x minus 2 squared. And I hope you notice, there's one little thing here to notice, is that negative 2 that we factored with, that was the number we had before we squared it back here in the earlier step. And we took b and divided by 2. We got negative 2, and that's what we ended up with when we factored. That will happen every single time you complete the square. So there's no magic here, no overthinking it. Whatever number you had back here, that's what's going to go here when you factor. And now you notice we're at the step we were when we were using the square root method, where I can just go ahead and take the square root of both sides. So that gives me x minus 2 equals plus minus the square root of 2. And then, of course, we need to get the x by itself, so I'm going to add 2. So we end up with x equals positive 2 plus minus the square root of 2. Okay, let's take a look at example 5. So they're asking us to solve the equation x squared minus 6x equals negative 10. Now, we could try to move the 10 to the other side and see if it factors. This is not going to factor, however. So let's see if this would be a good candidate for completing the square. You notice that the leading coefficient is 1, and the b value, that middle term, is even. So that's a good time to use completing the square. So let's go ahead and go through those steps again. First of all, if the constant is on the left side, you want to move it to the right side. Well, the negative 10 is already there, so I'm just going to leave it where it is. Then the next step, remember, is to take that middle term and somewhere off to the side, divide that middle term by 2. You always divide it by 2, remember. That's why we want the b to be even. So we get a value of negative 3. And then we're going to square that number, and we get a value of 9. So now that 9 has to be added to both sides of the original equation. So we get x squared minus 6x plus 9 equals negative 10 plus 9. And so I'm going to simplify that a little bit. We have x squared minus 6x plus 9 equals negative 1. And then that left side now is that perfect square trinomial that we need. Notice that will factor into x minus 3, x minus 3. You can skip this step if you want to, and go ahead and go right to the step where you write the x minus 3 squared. So if you wanted to go from this step to this step, that's okay, because you know the number here is going to be the number you had back here before you squared the b divided by 2 number. So negative 3 there, so I'm going to have negative 3 here every single time. Let's go ahead and take the square root of both sides. So the left side is just going to be x minus 3. The right side, of course, I took the square root, so I need plus minus. And if you remember back to section 1.4, recall what the square root of negative 1 is, and that, remember, was I. So this is going to have an I in our solution. We're going to have an imaginary solution. Go ahead and add the 3 to both sides to get the x by itself, and our solution then turns out to be 3 plus or minus I. So you may have imaginary solutions for some of these in this section if you ever end up with a negative under a radical. Just go ahead and use that I that we talked about. Okay, and then the last example, we have 3x squared minus 2x equals negative 4. And this is a good example where we would want to use a quadratic formula. Notice that it's not a good candidate for completing the square because a is not 1. It's not something that's going to be factored. Actually, it may be factorable, but I'm going to leave it the way it is. And let's go ahead and use quadratic formula. Quadratic formula is x equals negative b plus minus the square root of b squared minus 4ac all over 2a. And before you get too into this, to use the quadratic formula, you do need to make sure the equation is equal to 0. So I'm going to move the 4 to the other side. And so here's my equation. We have ax squared, bx, and c. So let's identify what a, b, and c are before we use the formula. So a is 3, b is negative 2, and c is 4. And you have to make sure it's equal to 0 before you identify a, b, and c. So let's go ahead and put everything together. We have negative b, which is negative of a negative 2, plus minus the square root of negative 2 squared minus 4 times 3 times 4. So that's 4ac all over 2a. And then we need to simplify what we've got here. So the 2 is going to turn positive Under the radical, we need to do the exponent first. I'd recommend that you do this by hand. Don't try to stick this in your calculator. We tend to mess up with the negative signs when that happens. So let's go ahead and do this by hand. Negative 2 squared is 4. We have one negative sign here. What I usually do is I look at the number of negative signs I have here and make a determination about whether it's positive or negative. 1, of course, is negative. If I had 2 negatives, that would be a positive. If I had 3 negatives, that would be a negative again. So we're going to have minus or negative 4 times 3, which is 12, times 4 again, which is 64. And I'm sorry, 4 times 3 times 12, that's not 64. That's 48. Sorry about that. Okay, and then underneath that, we've got a 6. 2 times 3 is 6. Let's simplify what we have under the radical. So we have 2 plus or minus 4 minus 48 is the square root of negative 44 all over 6. And then I'm going to take care of that negative. So I have 2 plus or minus I times the square root of 44, because we had the negative under the radical, all over 6. Now, I'm fine if you left the answer like this. Of course, I'd want you to include the I if it's needed, but you don't have to worry too much about simplifying these for me on a test. However, in my math lab, they're going to want you to simplify. So let's go ahead and simplify the radical first. We have the square root of 44. I'm going to come over here and work this off to the side. Square root of 44, that's equal to the square root of 4 times the square root of 11. So that's 10 times the square root of 11. So we come back and rewrite what we've got. We've got 2 plus or minus. We had 2 radical 11, so that's 2i radical 11 all over 6. And then let's go ahead and simplify what we've got. Everything that's there, the 2, and the 6, they're all divisible by 2. So let's go ahead and divide that. 2 goes into 2 once. 2 goes into 2 once. 2 goes into 6 3 times. So you may write this as 1 plus or minus 1i times the square root of 11 all over 3. In my math lab, they may ask you to separate this. So you would say 1 plus I times the square root of 11 all over 3, and then 1 minus I times the square root of 11 all over 3. And that would be your final totally simplified answer.